Alright, this is the first section that we did in the chapter on polynomials, and it involved using the laws of exponents to simplify expressions. So this is from the homework, but the classwork portion of the homework. So if you look at, pull it up online, you'll be able to see these problems. There we go, here's the first one. The thing we want to notice first of all is that everything in here is multiplication. Okay, and that's kind of important because this expression is a times b, and all of these rules, you can see we got multiplication up there again. All these things are for multiplying polynomials, and that's important to understand primarily because we're dealing with exponents, and exponents mean to multiply something times itself. So for example, this 3 up here means multiply this expression times itself 3 times. The negative sign means something different. In fact, you can see in rule number 4 it means the reciprocal of all of this. Now we can attack a problem like this pretty much in any order we want to. In other words, I could work with this negative here and apply this law of exponents, number 4, or I could use rule number 4 and deal with this negative exponent. We have a variety of options. The way I'm going to start is I'm going to use rule 3 and rule 2 essentially together. Rule 3 says if I've got things multiplied together, like I do, I can raise each thing to the power outside the parentheses. In this case, everything's multiplied in there, the exponent's negative 3. So I'm going to raise every single term in here to the negative 3 power. Okay, I'm going to show you every single step pretty much. For example, this negative 4 right here, I'm going to treat that as a negative, I could treat it as a negative 1. I don't want to confuse you too much. We'll just see how it goes, and then maybe I can clear up any questions you have in class. So I'm going to raise each thing to the negative 3 power, so it would look like this. Negative 4, raise it to the negative 3. G cubed, raise it to the negative 3. H squared, raise it to the negative 3. And J, it's a J, to the negative 2, raised to the negative 3. So it's a direct application of rule 3 here. A times B, raise A to the M and B to the M. And so negative 4 times G cubed, raise the negative 4, and the G cubed to the negative 3. Now, and I continue on with that idea. Now we apply rule number 2, which says when you have something with an exponent raised to a power like that, you multiply the two. Okay. Now you'll notice there is no exponent on this 4 in here, but when we don't show an exponent, the exponent's 1. So this is negative 4 to the negative 3 power still. I can't really rewrite that anyway. This is G to the negative 9th, multiplying the exponents, H to the negative 6, and J to the positive 6. I raised each thing. Next I'm going to apply rule 4, which says negative exponents mean put me in the denominator. I'm going to start moving stuff to the denominator, so this is 1 over negative 4 to the 3rd power, 1 over G to the 9th power, 1 over H to the 6th power, and finally J to the 6 already has a positive exponent, so I certainly wouldn't apply that rule to it. Okay, now I'm just going to multiply straight across on top. I got 1 times 1 times 1 times J to the 6. On the bottom I'm going to cube that negative 4 and get negative 64, G to the 9th, H to the 6th. And so that would be my simplest answer. Don't get confused here. This negative on the 64 means it's a negative 64. That has nothing to do with exponents and this reciprocal rule. Using the inverse or the reciprocal requires a negative exponent. That negative right there is not a negative exponent. So that's how you would simplify number 1. So I'm going to delete some of this stuff now so we can keep the rules up on the page, and we can look at another problem. And I did not want to get rid of all that. So let's take a look, if we can here, at problem number 2. Alright, problem 2 is 4k cubed over 3mn squared and all of it squared. So I'm going to get rid of this 2 first by squaring everything. So it'd be 4 squared. K cubed squared, which I just learned, multiply when you got a power to a power. I'm going to square the 3. I guess I should show that like I did with the 4. So you can see it. That's square the 3, square the m, and n squared, when I square it, I multiply the 2 times the 2 on the outside, give me n to the 4th. Okay. Now I'm going to go ahead and square the 4 and square the 3. And I am finished. So that would be my answer. 16 over 9, I can't simplify. They don't have a common factor. I don't have any. I can't apply rule 6 because I have to have the same bases. This base is k, that one's m, and that one's n. None of those are the same. And 2 is done. Alright, next up, problem number 3. 3 may be my last one. We got 3p to the 7th q cubed over quantity 2p squared q squared cubed, all raised to the negative 2. I think I'm going to take care of this 3 first right here. And when I take care of that, I'm going to go 3p to the 7th q cubed. I'm going to cube the 2. I'm going to p squared and cube it, so I multiply, power to a power rule. Q squared, I multiply the 2 and the 3. And all that's raised to the negative 2 power. Now something we learned in class is that when we have a big expression like this, it's all inside parentheses, I can simplify inside there. And so 3 over 8, they don't have a common factor. But p to the 7th here and p to the 6th, that's this rule right here. I've got a division. They both have the same base. In this in problem 6, or in rule 6 here, it says a and a, but in mine I've got p and p. And it says if you get m over n, subtract them. So I'm going to do p, and I'm going to do 7 minus 6, which is p to the 1st. The way I like to look at it when I'm doing this is I go, I've got 7 p's multiplied together, 6 p's multiplied together. 6 of them will just cancel each other out, making a bunch of 1s, p over p's, p over p, that's always 1. And so I'd have an extra p in the numerator, and that's what's written right there. Q cubed over q cubed, those simplify to just 1. And so now, oops, get my eraser. So now I've simplified this to that small simple expression. Now I'm going to get rid of this negative, and in class we learned this. Flip the whole thing over. Now it's to a positive exponent, and I can square the top and square the bottom. And I'm finished. Okay, there's more problems on that in this section that you can practice, and the homework problems are all solved online, so I would give those a shot if I needed more practice.